Good morning, ladies and gentlemen. Right now, we're going to start with a little catalyst just to get your brains flowing. First, I want you to think about how many particles there are in 1 mole. There's a few things we talked about before. And then I want you to use the ideas we highlighted in Mr. Astor's travels to attempt problems 2 and 3, dealing with how many hours are there in 362 minutes and how many minutes are there in 2 years. So take a second, pause the video, and give it a shot. All right. I hope that helped activate some prior knowledge, helps you remember the few things we're going to be working on for today. So first, a little thought experiment. First things first, think about some puppies. They're adorable, I know, but they're also really good for science, and here's why. Imagine you have 5 white dogs that weigh each 15 pounds. You also have 3 brown dogs that each weigh 10 pounds. You also have 1 black dog that weighs 20 pounds. It's the big one. How much do all these dogs weigh together? Well, this is pretty easy. What you're going to need to do is find out the combined weight of each of the dogs. So in this case, for the white dogs, each white dog weighs 15 pounds, and we have 5 of them. Each brown dog weighs 10 pounds, and we have 3 of them. And the black dog, there's only 1 of them, and it weighs 20 pounds. So we'd get 15 times 5, which is 75. 10 times 3, which is 30, and 20 times 1, which is 20. You add them all up, you get 50 plus 75, which is 125. This method right here is exactly what we're going to use today to calculate our goals. You ready to talk about it? Let's begin. Today we're looking at lecture 3.5, molar mass and gram to moles conversion. First thing I'm going to talk to you about today is molar mass. Let's discuss. We want to be able to learn today how to calculate the molar mass of any given element or compound, and then take any element and convert the number of moles to grams and grams back to moles if we're given a specific amount of that element or compound. So first, let's chat. What is molar mass? I think that's the first question we should ask. Molar mass in and of itself is actually really easy to think about. We've talked about 1 mole being 6.022 times 10 to the 23rd particles right here. That's 1 mole. 1 mole of anything has 6.02 times 10 to the 23rd particles of that thing. So molar mass is just the mass of 1 mole of anything, of any substance. And it's actually found on the periodic table for almost every element. In fact, every element that is in existence that we've discovered. Here we have carbon. And carbon, its atomic mass is 12. And that actually happens to be the exact same thing as the molar mass. So here we have 12, and the units of molar mass are grams over moles. So we have 12 grams for every 1 mole. And it's as simple as that. So how do we calculate this for certain elements and compounds? Well, I like to use tables. I think tables make everything easy. You list the element on the left side right here, the number of atoms in the compound right here, just like as I did with the puppies, the molar mass here, how much it weighs, multiply them out, you have the total molar mass of each element, and then add them all up together, just like I did with the puppies. It's the same thing. Let me give you an example. Here we have CaBr. So I'm dealing with calcium and bromine. First, I need to identify the molar mass of both of these elements. I think the best way to do it would probably be check out my handy dandy periodic table. Calcium has a molar mass of about 40. Bromine has a molar mass of about 80, 79.9. So let's say it's 40 and 80. Here, calcium with 40, the molar mass of 40, and bromine with the molar mass of 80. All I need to do is make my table. Calcium here, bromine here. I have calcium weighing 40 is the molar mass, grams per mole. Bromine weighs 80. Now, there are 1 calcium and 2 bromine components to every CaBr2. All we need to do multiply these together, and we're going to get 40 on top, 160 on the bottom. Add them together, I'm going to get 200 grams per mole of CaBr2. And so that's saying essentially if I have a CaBr2 molecule, calcium right here, bonded to two Brs, like so, that this molecule altogether is going to weigh 200 grams for every 1 mole. And it's as simple as that. So go ahead and try the same thing with 3 calciums, 2 phosphorus, and 8 oxygen in Ca3PO4, calcium phosphate. Give it a shot, and you'll find the answer on my wiki space. All right. So go ahead and give these 3 a shot right here. Calculate the molar mass of KCN, calcium nitrate, and aluminum sulfate. And I want you to try this bingo game right here. What you're going to do is you're going to take out a piece of paper, fold the piece of paper in half 4 times to make a 4x4 grid, just like this, and then write these numbers in right here. After you've done that, these are the bingo questions. Go ahead and play bingo with yourself. See after you've calculated the answers for each of these, where they fall on your bingo sheet, and just give them an X. When you're done, take a picture of your bingo sheet and upload it to your Google Drive and put it into my Dropbox. At the conclusion of that, I want you to give it a shot. How many moles of chalk does it take to write your name? And you can do that using the moles of chalk lab activity located on Mr. Astor's website. All right, guys, that does it for molar mass. I got grams to moles in your next video. Good luck. Let me know if you need any help. Up next, we got grams to moles.